Hello, I'd like to show you um, the concept of compound resource in the B2Bi REST API v2. Basically, these compound resources are to be used for promotion, for configuration promotion. That means that we support exporting an object with its dependencies and then be able to create on another system these three with the compound resource and its dependent objects. The prototype that you will see here is just at the beginning stage, and what we aim to show, not today, but with the prototype, is the ability to create FTP application pickups with all the objects that are needed by the pickup to be used. So I'll show you how it works, and I'd like to give you some details about the implementation. Of course, one option that we had was to modify all the classes to allow either to generate to extract a single object or object with dependencies. But that would have been a lot of overhead for eventually doubling the routes that we have, the models that we have. So um, we decided that an option would be to link the resources in a declarative way using add notations. So we implemented a linked resource add notation that is supposed to be used on compound resources. Like for instance, we have here an FTP embedded pickup bin that's going to store the configuration of the application pickup, and this links to some other resources. So we annotate the model with this link. For instance, an application pickup may have FTP subdirectories. It can also contain FTP users. And if we look at the pickup base class, we see that a pickup can also contain addressing rules, pickup groups, an embedded server, and even if we go to the exchange point bin, it can also contain some other resources like schedules, like inline processors, and we can imagine that we can collect like so all the dependencies. So with this annotation, we say something like if you will call a get, uh, we'll call the method that's going to read these objects without any information. Normally, it should return the content of this object without the dependencies. However, if you include a special FTP header telling the API, telling to the server that you also need to extract the dependencies, either you need to export them or later you need to import them when doing a post, for instance, then the engine will also visit the links and provide additional information or use the additional information that you will supply. So, how it works? This link resource annotation define additional resources. These resources can be embedded in the object or just included by the object. An embedded resource cannot exist by itself in the model. It needs to be linked to another resource. And when you delete this resource, you also delete the embedded resource. Whereas with an included resource, it can exist in the business model without having to have other resources that's going to link this. And when you delete resources which are using this, you don't have to delete this included resource. Apart from this split, they behave the same, almost the same. So we need a resource class which will be grouping together all the methods used to manage this additional dependency. This is a limitation that we enforced in the beginning, saying that normally you should group together methods which are managing a category of objects. So let's make it simple, keep it simple. Don't have to specify the resource class for each operation that you may have in your meta model. It is like all the operations should be defined in the same class. We can live with this, I think, up to what are the requirements up to now. Then we can define operations for create, read, update, partially update, and delete. So eventually we will have also an operation to check if the resource exists or not, like head, but we are not sure that this is going to be used in a promotion scenario. So imagine that you need to create or to extract FTP subdirectories for an FTP application pickup. Then you just define a link to the collection of these objects, specify which will be the resource class that will contain methods to manage these FTP subdirectories, and then define method mappings. Like for instance, when you get the subdirectories, you will need to call this method from within this class. Then we need to specify the binding of the parameters. And each binding contains the name of the parameters as it is defined by the method and the source for the value. And currently we support either a constant source. If you just put a string there, it will be passed with respect to some type conventions. So of course you will not serialize complex objects here, but just scalar values. Nevertheless, that's a constant value. It will be used as default value. Then you can make reference to some variables, and the syntax is similar to Maven variables, and you can use a prefix to get the content of the value from different contexts. Like for instance, if you need to take a value of a property from the container itself, from this resource, from the main compound resource, in this case is the application pickup, then you will use the this prefix and then the name of the properties. If it's a sub-object of a sub-object and so on, don't worry, you just put a dot to go inside the objects for properties, and that's all. Then, especially with the create method, you need to take the value of the argument for the sub-object, and that's gonna be the that prefix. Eventually you might want to call a method on the resource class, and then you can use as prefix the resource context. But the method that's going to be invoked will not have context arguments, will not have bindings, so should not have arguments. We will not supply any argument when calling this method, but the method itself should be aware of how to return the value that's needed. This is still under discussion to be clarified. So apart from this and that, resource is something that is not that common, and we might eventually change something with the mapping even for the resource context. Now, another thing that you might have in mind is that this method may return not the model itself, not the bin itself, but a wrapper on the bin, around the bin. So for instance, if it's a collection, then the values will be set as the value for the property results, and the collection may contain the total number of elements and some other information. So in order to extract some field from the response as being the content of the property itself, then you may specify here a dot separated list of properties. So if you need to go inside, then you just put what is the name of the root object that's wrapping the value, then sub-objects and so on. So this is the case with mappings for read. Create is similar, however, with operations that are not safe, that are altering the value on the system, the state of the system. These operations can be executed either after the operation has been performed on the main compound resource or before. For instance, when you create an FTP application pickup, you need to have an embedded server defined previously because you need to take the port of the server and configure the application pickup to use the port. So when we will export the configuration and then import it on another machine, we need a way to specify that the creation of the server should happen before creating the FTP application pickup. So normally we execute the compound operations that's creating the dependencies after we execute the main operation on the container itself. However, and you will not see here because we don't have the method to create the embedded server. It's not a big deal having it, but at this point of the prototype, we don't have it. However, creating the server needs to happen before creating the application pickup, as I said. So in order to specify that, we added a property that's called result bindings. So if you set on the method mapping this results binding property, this one, then what will be the purpose of having the results binding? It tells after you execute the method to create the sub-object, what do you need to take from where to set into the main object. So it's like after creating the FTP server configuration, you need to get the port that's allocated for the configuration for the server listener, and then use the port to set a property in the FTP application pickup. So these result bindings are actually a way of getting from the sub-object some properties and used to set some other properties on the main object of the compound resource. If we have this kind of bindings, then the method will be executed before executing the main method for the compound resource, just to be able to take the values that will be later used by the compound resource. However, the compound resource may be needed at this point. So when you create the server, you should get some information from the incoming bin for the main resource, for the compound resource. This is still available within your context when you execute the compound operation on the sub-resource, but be aware that this will not have an ID, for instance, because it was not created in the system. It's just the incoming bin to be used to create the compound resource. So this is how it works mainly. How it is actually implemented, we use Jersey on Jetty, but it can be used on other containers like on other application servers like Tomcat, even with Spring Boot together. But we just start Jersey directly. Jetty, I mean Jetty with Jersey. So what we do, we have a read interceptor. So the read interceptor will check if you are setting the special HTTP header that's going to be used to activate the compound mechanism. And if the header is present in your request, then it will extract all the values from within the embedded and included collection of the body. It will strip those values so that later on when the main method gets executed, it will be able to parse the body without even knowing that these values were there in the beginning. But of course, those values will be kept in the context of the execution of the operation to be later used. So this read interceptor just strips the unnecessary information for the main method on the compound resource itself, on the container, and then keep this for later usage. Then the method gets executed, and this is done by a method interceptor. We intercept the call just to be able to create the entity manager that is required in order to persist data, and also the main method together with the methods executed on the dependencies should go in the same transaction. So we start the transaction, we begin the transaction with the entity manager, and eventually we roll back if we get an exception, or in the end we commit the transaction. So this is how we can coordinate the transactions in only one transaction, including the execution of the main method on the compound resource and on its dependencies, and the method for each dependency. Then so basically, if we are talking about this, this is the prototype, but eventually, at some point, we have here an interceptor, and this interceptor is actually the one which um, is getting the entity manager, and it's beginning the transaction, and eventually it will have to call the treatment of the compound resources before executing the main method, because there might be resources that have result bindings that should be created before creating the main container, and then there are some additional resources that need to be created after we create the main container. So this is how it works with respect to coordinating the transaction. And in order to inject the information when you execute a get, we have a custom serializer which registers the module, and there are some additional properties that are collected with the final response. And there are three properties that we set. One is the links, which is already all the time available, so always you have that, and the links should point to some sub-objects, either embedded or included, which are linked to your main compound resource, just to be able to navigate to them. And then you will see them in the response. And then we also collect the embedded and included properties together with the dependencies grouped as such. So this interceptor is used to inject on the outbound stage to inject dependencies. So this is more or less how it is implemented. Now, if we go here, let me just refresh the page. You see, I have a tested FTP application pickup here, but I'm gonna create another one. So I have here a request. Let me just go to the body of the request, and the we currently disable the authentication just for the sake of the demo. But what you can see here is that I included the custom header saying that this should use the linked resources. It's in the canonical format. Um, you can use either the extended or without the extended. So the header tells what sub-objects you need to have, and in case you are executing a post, which is what I'm doing here, then you don't have to worry about um, you don't have to worry about um, saying what resources to be included here, because they will be in the body. Now, let me just try to get to the body of the object of the request. That was a previous response. We will see the response for the current request later on. So this is the main content of the application of the FTP application pickup itself. So it's going to create an FTP application REST with this name. But apart from the main object, we also have some embedded objects. Like we want to create an FTP subdirectory, we want to create a schedule for this, And we want to create also an included resource, which is going to be the FTP user. The relation between the main compound resource and the sub-resources could be one-to-many, but can also be one-to-one. So in case we have a server, for instance, we will have the server as an embedded resource, if so, but then this will not be a list. So the framework itself is able to detect if it has to perform the operation for each item of the list or just for one item, if it's not a list. So when we will call the method, the endpoint to create the application pickup, it will then first intercept the deserialization, extract and strip, get rid of the embedded and included fields, let the method deserialize the body, execute the main method to create the objects, try to execute before methods to create sub-objects if the result of the creation is necessary before creating the main object, but it's not the case right now. If we will have eventually a method to create an embedded server, then it will need to do so that before creating the application pickup. Then after creating the application pickups, those methods, those objects will be created by calling the appropriate method to do that. So when we call the method to create the objects, eventually the result that we got, it contains the information about the application pickup itself. If we go in here and refresh the page, you see that this is in error because we didn't create the embedded FTP server, but that's fine up to now. It will be, of course, in the prototype and eventually in the final version of the API. But for the sake of this demo, we didn't implement that. So let's just go back to the result. Apart from the information about the application pickup itself, it also contains the links. So you see that there is a server that was found and it's linked to this. This is actually the default embedded server. We don't create one, but it should be one already defined, I think. Then there are some addressing rules, some schedules which are available, some FTP users that we create, also some FTP subdirectories. So all the links are available and we can navigate, and if we go here, we will take the value from the API because they are referencing an active path of the API. So there are listeners and there are methods that will be invoked when we go there. Now, we also have included resources, and we got information about the server, we got information about FTP users, and as you may see, even those may have their own embedded or included resources. So eventually we will not save empty values, which is the case here, but be aware that there is no limitation in how much it will go in deep. If we have a resource with some sub-resources and so on, they will be listed, and you can use the filter to reduce this visiting of the model. Then we have some embedded resources, like for instance the addressing rules, some schedules, and the subdirectory that got created. So if we go in interchange UI, you see this is the resource that we created, and this has a subdirectory, and if we the subdirectory, it's also the access to the subdirectory is also configured. So we also defined a schedule for this, and this is the schedule that we created. So all the information is there that has been created from the incoming message, the one that you may see here. So basically, this is how it's supposed to work. There are some limitations though. One of the limitations that you noticed is that we it depends on how we execute the methods. And for instance, one limitation is that let's suppose that you need to have one resource created before the other. One way to do that would be we save. So what happens behind the scene when you annotate your classes? This annotation is processed by a source annotation processor, which will save a JSON model together with your class, close to your class, in this case close to this, and this will contain information about the operations that you set there. So for instance, if I then go to, let me just show you where it is. Let me just go to show this in the System Explorer, and let me adjust so you can see it in here. So after compiling the model, that's already in the jar. But if we go in the extracted structure of the classes, you may see that eventually for the model, let me go there. So for the model, you have some files, like for embedded pickup, application pickup. If we go in here, come on, let me just. Yeah. So try to put this in your view so you can see it better. So nevertheless, what I was trying to say is that we save this model based on your annotation. So we say what are the embedded resources, what operations you need to perform in order to read the objects, what are the mappings of the values. So this model is available at compile time. We chose to use this as a JSON file, because if you need to change something in your already running system, you just have to go there and modify the file without having even to recompile the source code. Nevertheless, this this model is then used at runtime. So visit the resources only once at compile time. If it takes longer, it will affect the time of building your artifacts, but it will not affect even the time of wiring up your system. So it goes smoothly, just reading the document and the file and being able to map and cache the mappings with reflection to the methods which are then set there. So I was trying to say that one limitation is the order in which the methods are invoked. So one option, and this is what's happening right now, is that we execute the methods as we find the linked resource in the source code. So if we have several resources, methods on this one will be executed before this one. However, we group them by embedded and included. So it's not quite like so. We currently we execute first the included methods on included resources, and then methods on embedded resources. I think in the end we should stick with the order in which the annotations are defined, so that the user can control the way the resources are executed. Because, for instance, in the demo that you saw, in order to be able to create a subdirectory, we should create the FTP user first. So it depends on the order the operations are executed, and the user should know that and be aware of that, and should have a mechanism to control the order. Now it has, but it's not that strong. So because we execute the methods on included resources before the ones on embedded, it cannot be mixed. So cannot start with an included resource method call, then go back to, then continue with an embedded method, and then continue to included methods and so on. So this is something that is subject to be analyzed further and changed. Apart from that, this is where we are, and currently we tested with get and create, but we implemented a mechanism to go with the other um, uh, CRUD operations. However, there are slightly differences, especially when doing a post or a patch on collections, and this is something to be subject of change in the implementation of the prototype, and we will come back with the solution later on when we will have it. So thanks for watching, and we'll get back to you soon with more details about the prototype and the rest of the operations. Thank you.